in physics and indeed in sciences and maths more generally, there are lots of quantities that we can measure. An example might be power or energy or force or electric current. And these quantities fall generally into two groups. One of the groups is called vectors, we can see that here, and one of the groups is called scalars. So we have vector quantities and we have scalar quantities, and these are the two types of quantity, types of measurement that we can make in physics. And this video explains how we identify which one's which and what the differences are between them. I'm going to start doing that with the example of a box. So here's a box, just there in abstract space, if you like, and I'm going to identify two quantities related to the box. The first one is the temperature at this point inside the box, and we can say that that might be 19 Celsius. And I'm going to identify the weight of the box, and I'm going to represent that with a force arrow. That's its weight, and we can say that the box might be 4 newtons in weight. Okay, so immediately we can see there's a difference between these two quantities. One is represented by just a dot, and one is represented by an arrow. So one of them is a vector and one of them is a scalar. The difference is, well, let's start with the similarities. The similarities are that both of them have a magnitude. So the magnitude is the size or the number related to the quantity, and we can see that the magnitude or the number related to the temperature is 19 degrees Celsius, and the magnitude or the size of the force is 4 newtons. So 19 Celsius is the magnitude of the temperature and 4 newtons is the magnitude of the force. No differences yet, those are the similarities, because vectors and scalars both have a magnitude. They both have a size or a number, but the difference is that vectors also have a direction where scalars do not have any direction associated with them. Looking back at our two examples, we can see that it's the force that's the vector, because the force has a direction associated with it. It acts downwards, vertically downwards towards the centre of the Earth. Whereas the temperature doesn't really have a direction. It's meaningless to say that the temperature in the box at this particular point is 19 degrees C in any particular direction. That just doesn't work. It's just the temperature. So the temperature is the scalar, and I've got that in my example. Temperature is a scalar because it has no associated direction, just a magnitude, but force is the vector because it has both a magnitude and it has a direction. Okay, so the general rule is if you can point in the direction that this particular quantity acts in, then it must be a vector. If it doesn't make any sense to point in any direction, then it's probably going to be a scalar. That's an easy way to remember how to identify them, because one of the jobs you've got is to be able to identify scalars and vectors from a list of quantities. So let's have a look at some vectors and scalars in our topic and see if we can identify which is which. So here we are. Now the first 4 are grouped into pairs. There's a pair there and there's a pair there. And the reason they are pairs is because they're measured in the same unit. They're the same type of quantity. So for example, distance is measured in meters and displacement is measured in meters. What's the difference then? What's the difference between distance and displacement? Okay, well here's another example. Let's take a swim, somebody swimming in a pool. So here's the pool, and let's draw the water in the right colour. Here's the water, and then we've got somebody swimming. Let's draw them in green. So here's the person swimming. So they start off at this end of the pool, and they push off the side. Let's just draw them as a stick person, on their back probably, doing a little bit of backstroke. They push off the side, and they set off. Now let's say it's a 25-metre pool. So they swim along here and all the way along to the other side. There we go. And by the time they get to the other end and they do their little turn ready to come back again, they've travelled a distance of 25 metres. Right? That's the distance that they've travelled. In terms of where they are in relation to their starting point, they are also 25 metres away. Now in our diagram, they're 25 metres to the right. So that's fine. Both those ways of looking at how far they've travelled are the same at this point. But now the person has a change in the direction that they are travelling. A change in direction, and this is important, obviously, because vectors relate to direction. Now, let's say that this person swims back in this direction towards where they started, and they get halfway back. And let's stop them there and see what's happened to their distance there. They've gone 25 metres there and half of 25 metres back, which is 12.5 metres. So they've gone a distance of 37.5 metres. And now hopefully you can see the difference, because if we examine the distance from where they started, or how far away they are from their starting point, they are now only this far away, which is now 12.5 metres. So now the distance that they've travelled and their distance from the starting point in a straight line in a particular direction, left to right, are different. So they've gone 37.5 metres, they carry on, they keep going, they keep going, they keep going, and they end up back where they started. So now they've travelled a total distance of 50 metres, but the distance in the particular direction left to right from their starting point is 0. They effectively haven't gone anywhere. So one of these is the distance that they've actually travelled, and one of them is the displacement. One of them is a vector, and one of them is a scalar. So the distance, this top one here in the list, let's go back to the list over here. This one is actually a scalar, and it's literally how far they've gone. But the displacement is this bottom one, this one over here that we've been looking at in just here, is actually the displacement of the person. And the displacement of the person is effectively their distance from the starting point, or any fixed reference point, if you like, starting point in a specific direction. And because of that little bit at the end there, this is the bit that specifies the fact that the displacement is a vector, because we're interested in the distance in a particular direction. Okay, so displacement then is a vector, and distance is a scalar. Okay, let's have a look at the next two, because they're a pair as well. They're a pair because they're both measured in meters per second. We have the speed of an object and its velocity. We kind of use these words interchangeably in physics, but actually there's a slight difference between them, because speed is a scalar and doesn't take into account at all which direction you're going in. So for example, in your car, you're going down a road, you could be travelling at 30 miles an hour or whatever. That's the speed that you're going at, and there's a speedometer to tell you your speed, but it doesn't tell you which direction you're going in. The velocity, however, is a vector, because velocity is your speed in a specified direction. I.e., let's take a plane, for example. A plane might be flying at 140 miles an hour due north, or 290 miles an hour maybe, due west, or whatever. So there's always a direction associated with the velocity, because the velocity includes the speed and the direction of motion. So hopefully you're getting a sort of an appreciation of how to work out which quantity is which. If there's a direction associated to it, it's a vector. If there's no direction associated to it, it's a scalar. So let's have a look at these. Acceleration, let's look at this one here now. Acceleration. What do we think that one is? So is there a direction associated with the acceleration? Well, yes, there is. If I drew a little car down here, a little lab cart or something, let's say it's travelling, it's got a little motor in it or a little fan which is causing it to speed up or accelerate. It's accelerating in that particular direction towards the right, which puts acceleration in the vector category. Force we've already talked about with the box, that's a vector. Weight is an example of a force, so that's also a vector. Mass. Now, this trolley down here has a mass of, 2.4 kilograms. That mass doesn't act in any particular direction like the weight does, it's just the mass of the object, so it's just the magnitude. There's no direction associated with mass, so mass is a scalar. Momentum is mass times velocity, which we'll learn later on. Momentum is a vector because you can point in the direction of an object's momentum. It's got a certain momentum in that particular direction. Energy has no, it's pointless to say that a kettle has 2,000 joules of heat energy to the left. That doesn't make any sense. So energy is a scalar, and power, likewise, if something's generating 200 watts, it's not doing it in any particular direction. So power is also a scalar. So the bottom thing to remember is, if you can assign a direction, or think of a direction that this object, that this quantity acts in, then it's got to be a vector. If you can't, if it doesn't have one, then it's a scalar. All right, so just to return to the definitions, just so we remember them, a vector is a quantity that has a magnitude and a direction, whereas a scalar is a quantity that only has a magnitude and no direction at all. And that's it.